I decided to build an electrolysis rig, and I thought I could just show you what I came up with for a setup. I guess the first thing I should say is a disclaimer. This is not in any way a how-to video. This is just showing you what I've done for my project. And as always, you need to be really, really careful when dealing with electricity. But that being said, I'd like to show you what I did. I decided to build a setup because I have some iron relics that were found metal detecting. I have this hook and this aux shoe, and this is a draw pole that my daughter actually found in our backyard. And my goal is to remove the iron rust from these. I'm going to start with this hook, and obviously I want it to look better and I want to preserve it. Now, as far as removing the rust, there are different ways that can be done, and you know this. You can use a mechanical means, like using a wire brush, but that can be time-consuming and messy and can scratch the surface of the relic. You could also use a chemical to dissolve the rust, something like navel jelly, but obviously those sorts of things have to be purchased, they have to be properly stored. Some of them can be hazardous to use and dispose of, and the chemical reactions can alter the surface of the iron. It could etch it or could pit it if you're not careful. Another way, which is the way I'm going to try, is to remove the rust through electrolysis. And I think electrolysis is really interesting. It's a way of using electricity and a liquid to dissolve rust from one object and transfer that rust through a solution to another object. So the electrolysis dislodges the rust from your relic without damaging the surface. And it sounds counterintuitive, but it works, and it's really pretty effective. Now, as far as the rig that I built, this again is not a how-to video. It's a basic electrolysis rig, and it can be put together with things that you have lying around your house. These are all pretty much things I had lying around my house. It doesn't have to be an expensive setup. There are basically two parts. There are power supplies, power sources, and then some sort of electrolysis tank. And I'll start with a power source. All right, as far as the power source, you can use different things as a power source, but the power needs to be direct current, the kind that comes from a battery or a converter. And I have this laptop charger. Laptop charger's input AC through this end. That's the type of electricity that comes from your electrical outlets. And it changes it. It converts it to DC current, which is usually the type used to charge a battery, like the one in your laptop. Now, that converted DC current can be used for other things, like electrolysis. This is an HP laptop charger that I converted to an electrolysis power source. I put some alligator clips on this end. And this would work just fine, but you have to check the voltage of these sorts of things. This outputs 19.5 volts, which again would work perfectly fine for electrolysis, but it is a little bit high, and I want to do this process slowly. It's not a race. So I bought this unit because I think the best voltage range is somewhere between 8 and 12 volts. And this unit I ended up buying on Amazon. It cost about $12, and it provides variable voltage based upon this dial. So it'll output whatever voltage you tune it into. It had a barrel end, it had an end like this, because again, this is a laptop charger, and I just cut it off. I peeled back the outer insulation, just put some tape down there, and that left me with a red wire, positive, and a black wire, negative. I stripped the wire off the ends, and I just attached these alligator clips. So you strip the wire, you push it through this end, goes up through this hole, and there's a screw terminal there, screw it down. Then you crimp the end with, if you have a wire stripper, the end of it should crimp. It just presses that down so this wire does not move. And then you have this little collar that slides over it. And the same thing with the black side. So that was easy enough to do. Now, I have not used this power adapter yet. So what I'm gonna do is plug it in and I have a multimeter. I'm going to test the voltage just to show that the voltage that is displayed on this display matches the voltage that the multimeter is registering. So let's give that a try. Okay, so there's the voltage adapter, there's the multimeter. It's set to measure volts DC, which is the voltage that this is putting out. I'll take the black probe from the multimeter, connect it to the black wire, the negative. Connect the red to the red, positive to positive. Turn this on. And here we go. So this is saying it's putting out 6.6 volts. This is measuring 6.6. Let's bring it up to maybe 8 volts. So that's just dancing around 8 volts, as is that. Let's bring it up to 12 volts. And there too, that's 11.9, that's 12.0. So this is pretty accurate as far as the voltage that it outputs. So that'll be good. I'll be able to vary the voltage as I need it with the electrolysis rig. All right, the second part of this electrolysis setup is the tank, the electrolysis tank. This is where the magic happens. Now I'm doing this in my garage. You want to do this in a well-ventilated area. It can be a bit messy, but there's nothing dangerous as long as you do it right. Nothing dangerous is going to occur, but probably not something that you want to do in a living area. This is a plastic bin. I bought it at Target. It ended up costing me about $4, and it has a lid, which is nice. So when I'm done this project, I can clean everything up and store everything in here. You want a plastic bin because plastic is non-conductive. You want the electricity to stay in the solution. I have a metal spring clip, which is attached to the sacrificial metal. This is the metal to which the rust will attach. And the nice thing about a magnetic clip is that I can clip the alligator clip right here, and it's going to conduct the electricity through there. It also is red to remind me that that's the positive side. The sacrificial metal that I use is just a piece of steel that I had lying around. You can use anything that's ferrous, that's magnetic. It'll work just fine. Just needs to be clean. Can't be anything that's painted, can't be anything that's coated. Now on the other side I have this piece of wood, again, non-conductive. And I have a piece of copper wire that I have from a home wiring project. The copper wire will be connected to the relic, and then the negative, the black alligator clip, will be connected to the top. And that will take care of that side. Okay, here we are at the point where we have to add the liquid, the electrolyte. How do you make an electrolyte? Well, this is tap water. I don't know how much I have in there, maybe about 4 gallons. And you have to add a chemical to it. You have to add an electrolyte, which will create an electrolytic compound. It's dissolved in the water, and it will take on a charge, and will carry the electrical current. So the one I have, the one I'm using, is this laundry booster, this washing soda. I understand it works really, really well. There are others that you can use. You can use baking soda, you can use salt, but I had that in my laundry room, so I figured I would give that a try. But they'll all work. You just want the solution to become electrolytic. You want it to become ionized so that it can conduct electricity and absorb the rust particles in the solution and transfer them from the relic, which will be there, to the sacrificial metal. Another thing to keep in mind is that both the metals, the relic and the sacrificial metal, should be suspended in the solution as much as possible, because that allows for more surface area to react with the electrolyte. So more rust can be taken from the relic, passed through the solution, and deposited on the sacrificial metal. As far as the time involved, I'm not sure. I think it depends upon the current of the power supply, and it depends upon the amount of rust that's on your relic. So it could take a few hours, it could take a few days. Just do it slowly. That's what I'm going to do. I'm not going to do this overnight or leave this running overnight, just in case something goes wrong. But I'll monitor it, keep an eye on it, and see how it does. All right, I'll just slide that down for now. This is about a 1/4 cup. This probably is actually more than I need. Put that in there. Then you mix it up. Now we'll let it set for just a moment. Let everything dissolve. Move that back. And we'll take it from there. Okay, here we go. So there's the hook. I wrap the copper wire around it. I will dunk it in the solution. There we go. So now I will turn off the camera. I'll connect the negative to the relic. I'll connect the positive to the sacrificial metal. We'll plug it in, set it to 12 volts, and see what happens. Okay, so I've connected the red wire, the positive, to the sacrificial metal. The negative is connected to this copper wire, which is connected to the hook. Everything's suspended in the electrolyte. Let's see how it goes. If this works, we should see bubbles on the hook. So let's turn this, let's put it at 8 volts. All right, that's just there at 8 volts, and you can tell. Let me take the phone off this. You can see the bubbles coming off that wire. That tells you that this process has started. So I'll let this sit for a little while, probably for about an hour. I'll come back and show you what it looks like. Okay, it's been about 2 hours since the hook has been in the electrolysis bath. And it's pretty bubbly in there. But you can tell that is what the sacrificial metal looks like now. And on the bottom, there's a lot of rust. That has dissolved and transferred. Looks like the hook still has a little way to go. Still bubbling really nicely. I'll leave it in there for another few hours anyway, and we'll see what the final product is. What I'll probably do is finish this hook and then maybe do another, I have another piece of sacrificial metal, do another relic, and I'll make a short video a little bit later on to show you how they all come out. But that's pretty impressive. That's still at just about 8 volts. I think let's crank it up a bit. Let's bring it up to 11.5 volts. But yeah, pretty amazing, I think. So look for the other video that has the final outcome. Have a great day.